Okay, hello everyone. Good evening. Uh, Myself, Anjan BK, working as an assistant professor in the Department of Civil Engineering. And today we are going to start our GATE session on Geomatics Engineering. So let us start with this contents in the GATE. So we have principles of surveying, and we have errors and their adjustments, maps, scale, coordinate system, and the distance and angle measurement, and a few numerical problems on them. Leveling and trigonometric leveling, traversing and triangulation survey, horizontal and vertical curves. So these are the things I will be covering. And my colleague Girish has already covered the photogeometry and remote sensing previously. So let us start. So what is actually the definition of surveying, or in modern days it is called geomatics. It is nothing but the science of making measurements of the earth, specifically the surface of the earth. So what we will be doing is we'll be finding, or we'll be collecting the relative or absolute points, details, or finding uh, the surface details or measurements above or below the earth surface. So basically, there are two divisions primarily. One is geodetic surveying, another one is called plane surveying. And geodetic surveying means in which we will be considering the curvature of the earth. So you can see here, if you are considering the curvature of the earth, then we call geodetic surveying. And the plane surveying is we consider the earth is flat, that the curvature will be neglected. So basically, let us see what is the difference between plane and geodetic surveying. So in the plane surveying, the earth surface is considered as plane, whereas in geodetic it is curved. And the curvature of the earth is ignored in plane surveying, whereas curvature of the earth is considered. So if you want more accuracy, we'll go for geodetic surveying. And the line joining any 2 points in plane surveying is straight line, whereas in geodetic it is spherical. And the line which we are joining in a triangle formation with 3 points, it is considered as plane, whereas in geodetic it is again spherical. And the angles are plane angles in plane surveying, whereas in geodetic surveying it is spherical angle. And generally it is we take any area measuring with less than 250 kilometer square will be considered as a plane surveying. And any area if you are measuring more than 250 kilometer square, so normally that is uh, divide are classified as geodetic surveying. So the survey department of survey of India will be conducting the geodetic surveying, and normally the survey what we do for local regions will be plane surveying. So what are the fundamental principles of surveying are? There are two basic principles. One is always we have to work from whole to part, which means we will be having a certain area, and we cannot measure the complete area with one stretch. So in order to measure and in order to make our work simplified, so what we will do, we will actually minimize the area into smaller portion or smaller parts, and then we will be measuring the area of these small parts, and by summing up all this, we will get the total area. So for example, if you take a line, a total length of the line, which cannot be measured in a single stretch. So what we will do, we will identify intermediate points, and we will find the distance between the each points, and then we will add all the distances. So by adding all the distance, we will get the total length of the line. So this is called whole to part. So this is entire work is the total length. The total length will be subdivided into a smaller lengths, and all the small lengths are nothing but parts of the whole entire work. So this is one principle of surveying. Second principle is, in order to locate any new station, we must have two measurements, which means at least we should have either linear or angular measurements. Any one of these, or if you should have two linear measurements or two angular measurements. So these are the uh, uh, things one should know. That means if you want to fix a new point, you should have a control point. What is the meaning of this? It means, for example, to start this survey work, we should have two reference points, which means we should have a reference line. And in order to find the new point, that is the third point, first is either we should have the length of this point 80, and length from two details are needed, length L1 and L2. Or we should know what is the length, and we should know what is the angle of this particular line. Then also we can find this new point. Or we should have two angles, theta and alpha, where these two lines will go and intersect with certain angle. So that is also new point. So like this, we should have two measurements in order to find a new position with respect to two control points. Coming to scale, this is one of the important topic which will be asked in the game. So what is scale? Scale means it's a plane which is representing the ratio of line on the map, the length with the same line on the ground. So on the we will be measuring in terms of kilometers, but on the sheet or on the drawing sheet, we will be representing them in terms of reduced lines. So that is where we require scales. So we have uh, representative fraction, that is called engineer scale. So which means 1 centimeter on the drawing sheet will be equal to 40 meter on the ground. So this is how we represent in the engineer scale. That is in the fraction, it can be measured in same units. So 1 centimeter divided by 4000 centimeter. 4000 centimeter is nothing but 40 meters. So here is an example for that. If you have any wrong measurements, and if you have taken any length as with the different scales, then how to calculate the correct measurement. So for example, if a plan you are having drawn on a scale of 1 is to 200, and the length is measured with the scale with a fraction of 1 is to 250, then there is a difference. The scale drawn is 1 is to 200, but the measured length is 1 in 1 is to 250, means there is some error. So in order to find the correct length, so there is a formula, that is correct length will be equal to the RF, that means representative fraction of the wrong scale divided by correct length into measured length. So for example, similarly, the area can also be calculated. Correct area can be calculated by squaring up the refraction factor of wrong scale by correct length. So here is one question asked in the gate. The representative fraction of 1 by 2500 means that the scale of 1 centimeter is equal to how much? So I already told you that the units, the measurement unit in representative fraction will be same. So 1 centimeter is nothing but on this drawing will be equal to 2500 centimeters. So what will be the correct answer? You can just check. So 2500 means centimeter means is nothing but 25 meter. So you have this 25 meter. So to confuse, it is given in number 0.25, which is wrong. 2.5 means it is just 2.5 meter is nothing but just 250 centimeters. So this is also wrong. So the correct answer is 25 meter. So you should know that in the representative fraction, both the denominator and numerator will be in same unit. Okay, next question is, the plan of a map was photocopied to reduce size a line original 100 mm is 50 mm. The original scale of the plan was 1 is to 1200. Then what is the revised scale? So you can observe that the original length as that is 95 means it is 5 mm shrink. If it has shrink means there will be definitely there will be an increase in the increase in numbers, increase in the scale factor. So how much it will be increased? You need to find the correct length, correct scale now, revised scale. The original length is 100 mm and the shrunk length is 95 mm. So the ratio we can calculate, that is in terms of centimeters, 9.5 by 10. So then what is the scale will be? The original scale is 1 is to 1 1200 into the shrinkage ratio. If you calculate this, and the ratio which comes out to be 1 is to 1263. So this is the answer. So the tip is normally most some of the times you can easily see that the scale ratio has increased from was 1200 to 1263. So that is the one hint. Sometimes you can observe these options, sometimes they will be lesser than the original scale, that is 1200. So then also you can directly select the answer. So you have to observe these uh, values. And there will be a problem sometimes, a chain may be too long or too short. So whenever the chain is too long, then the error will be negative, therefore the correction should be opposite to that, that is positive. So if it is too long, then the correction is positive, and if it is too short, the correction is negative. So that means the overall correction we need to consider. And some of the corrections required for temperature, if it is uh, you are conducting a survey in a summer, then normally due to temperature it will elongate. Elongation temperature will be positive. If it contracts, then your correction will be negative. So the error will be positive and correction will be negative, vice versa. So like that. The correction for pull is always positive, correction for sag is always negative, and correction for the slope is always negative. So this is a formula for calculating temperature correction. And then this is the formula for calculating the correction for pull, and this is the formula for calculating the correction for sag, and this one is the corrections for slope. And there is one more thing which is called normal tension. When the chain is pulled from both the sides, so what is the amount of tension which is developed? Normally they will ask a question on this. So you need to remember all these formulas in order to solve the problems on errors. So here is a question. A 30-meter metric chain is found to be zero point 0.1 meter too short means, so absolutely it will be, the correction will be positive. Correct. So we have seen this here. If it is too short, then the correction is always uh, negative. That means error is positive. So throughout the measurement, if the distance measured is recorded as 300 meter, then the actual distance measured will be. So we have to find what is the actual distance for this. So it will be normally too short means, so the measured length will be normally more. So therefore, so you can observe here the answers are more than the measured length, which is all wrong. Okay, so the one which is correct is the one which is lesser because the chain is too short. Okay, so the answer should be lesser than 300 meter. So that is 299 meters. A 100-meter tape is suspended between the ends under a pull of 200 newton. The weight of the tape is 30 newton. The correction for sag and correct distance between the tape ends is. So they are asking two questions here. What is the correction for sag and what is the correct distance between the tape? So you have to first find the sag correction. So that is using the formula here. Using this formula, you have to find the sag correction. So that comes out to be 0.094, and if you deduct that with the measured length 100 meters, so then you will get the correct distance, that is 100 meter minus 0.094 is 99.906 meters. Coming to the measurements of angles, bearings. So we have two systems in to measure the angle, that is whole circle bearing system and quadrantal bearing system. So in whole circle bearing system, you can observe here in this first figure, the angles are measured always with respect to the rough north and south. So if you have a line here, the line here, the means you will be measuring angle with respect to north. Same way, if you have a line here, the measurement will be with respect to south. Similarly, if the angle north, so that is whole circle bearing system. In quadrant bearing system, the angles that the we can subdivide into four quadrants. So that is northeast is one quadrant, second quadrant, third quadrant, and fourth quadrant. In each of these, it will be divided into 90 degrees. Whereas in whole circle bearing system, it is the complete 360 degrees. So the quadrant bearing system normally represented with north n angle in terms of theta and east. So first thing always comes either north or south will come first, and then followed by east or west. And next is magnetic declination. What is that magnetic declination? Declination means you have true north and true south. So if the magnetic needle is differed from a true north by certain amount, then that is called magnetic declination. If the declination is towards the east side, means towards from north to east side, then that is called eastern declination, or it is called positive. And if the declination is towards the western side of the north direction, then that declination as western declination, or it is also a negative declination. So for example, you have a line and followed by this is the true north, the difference in angle between the magnetic north and the true north is called as magnetic declination. If it is towards east, then it is the declination is positive. If the magnetic declination is towards left, that is towards the west, then this is and this declination will be negative, western side. So here is a question. If the forebearing of a line AB is 35 degree and that of the line BC is 15 degree, then the included angle between the line is. So the system they are given is you can draw a forebearing of the line AB which is 35 degree, and from B to C it is 15 degrees. So this angle degree. So they are asking us to find the included angle. So there is two possibilities. They may be asking either this one or this one. Of them will be the answer which will be given here. So that is nothing but you have to first find out what is the back bearing. So that means so we'll have a 35 degree bearing for A to B. So therefore bearing will be 180 degree plus 35, which is 215 degrees. And then the forebearing of the next line. The forebearing of the next line is BC. So this angle is given as 15 degrees. So out of 215, if you deduct 15 degrees, you'll get 200. This side is 200. So the 200 degree option is not at all available answer. So therefore, that means the other side they are asking. That means 360 degree, because they are not given whether it is conducting in clockwise or anti-clockwise. So sometimes students get confused. So we are getting 200, but the option is not here. But they are asking the other side of this line's angle. So this you can get 360 degree minus 200, which is 160 degree. You can see is available here. So that is you have to find the answer for the side. We have to check for both the sides. So they are asking included angle. So answer is 160 degree C. Okay, here is a declination problem. You have an world map line drawn to a magnetic bearing of 10 degree 30 minutes. The magnetic declination being 2 degree east at that time. The magnetic bearing to which the line should be set, the present magnetic declination is 4 degree 30 minutes west. So here is two condition. One is you have earlier the magnetic bearing is given, but with respect to magnetic north, so if you measure the angle, so this is the line, this angle is 10 degree 30 minutes. At the time when it was measured, it is having a declination from true north to magnetic north with 2 degrees. So the true bearing at the time of measurement is, it's not actually 10 degree because it is towards east, means 10 degree 30 minutes plus 2 degrees. So therefore true bearing will be 30 minutes. And this is the true bearing. This true bearing means it is not going to change over a period of time. So the next time when it is measured, you can observe the declination is 4 degree 30 minutes west. So that means the magnetic declination is going to change, but true bearing is never going to change. So therefore, we'll have to write once again true bearing with a true north. That is, we have a line, and now the magnetic north is having 4 degree 30 minutes west. So this line. So just change the color. So this is our magnetic north. So because it is towards the west by an amount of 4 degree 30 minutes. So now the magnetic bearing will be from the magnetic north to this line. So therefore you have to calculate that is 4 degree 30 minutes. So you have to add 4 degree 30 minutes to this particular true bearing, which is 12 degree 30 minutes. So you'll get the answer for the uh, ma- magnetic bearing for the present time. So the answer is, okay, if you add 12 degree 70 degrees. So you can see the answer here. The 17 degree, it is the correct answer. So coming to the part of leveling, measurement process where we will be finding the difference in elevation or difference in height between the 2 points. So therefore there are weak curvature effect which will be coming to picture, and refraction error, which is curvature error due to the uh, earth surface, and the refraction is error is due to the uh, you can say the focusing or the observation due to from the telescope. So the total combination of error is given by this formula 0.0673 d square, and only the curvature correction is given by this formula. So you need to remember these numbers because directly sometimes these questions will be asked. Using these formulas, you can find the corrections. And normally this distance you have to substitute in terms of kilometers. So please remember, you will get the corrections in meters, but the distance you have to substitute in kilometers. And one more thing is reciprocal leveling, where we will be finding the true elevation between the 2 points which are having apart from a certain length. So normally, so what we have is in the curvature theory, if you draw an horizontal tangent line, of this coinciding projection measurement length is only 100 meters. So if you are positioning your leveling staff more than 100 meters, so therefore there will be a curvature effect. So for example, if I am going to place my leveling staff anywhere in this line, in this point, then the elevation will not differ so much. But as soon as we put our leveling staff somewhere here and keeping it at a certain level, then we can observe there is a certain error, because our instrument will be sitting here and it will be measuring elevation with respect to its current ground position. So this is a total error which is not true. So we need to consider this, because the curvature needs to be considered in order to get the true elevation. So therefore there we will do reciprocal leveling. What we will do, we'll set up the instrument near station A and we'll observe two readings. Again we'll set up an instrument at B, again we'll take the two readings. So here is a problem. The RL of the point A, which is on the floor, is 100 meter and backside reading is 2.455 meter. If the foresight reading on the point B, which is on the ceiling, is 2.74 meter, then the RL of the point B is. So if you're holding the leveling staff at the ceiling, means you will be holding it upside down. So that means, so your leveling staff is not grounded on the ground, it will be upside. That will be the reading you have to take as negative. So therefore, so we'll draw a let's put up it in a table form. So we have a backside. The backside reading is 2.455, and the foresight reading at point B is ceiling, means it is inverse. So inverse reading means, so this is point A, this is point B. Inverse reading is recorded with negative sign, 2.745 meters. And we know what is the RL. RL of the point A is 100. So we have to find what is the RL of point B. That is the question. So what is the RL of point B? So it is quite easy that you have to find the either using rise and fall method, or you can use the HI method. So using HI method, you can find what is the height of the instrument, that is 100 plus 2.455. So height of instrument will be 102.5, and the formula to find the RL is HI minus the intermediate side or the foresight. So HI is 102.455 and plus of minus, because this reading, so that will become plus, so 2.745. So you need to add 102.455 plus 2.745, that will give you the RL. So the RL is it will be equal to 105.2. And there is a, you can observe here, these are the readings which are lesser than the RL of A. See, assume that you have a dumpy level fixed here, and you are taking a reading 1 here on point B. This is point A, and 2.455, and you are the inverted side and you will be measuring this length. That means the RL of point B is, of course, should be more than RL of A, because RL of A is 100 and height of instrument is already 2.455, which means the RL of point B should be certainly more than RL of point A, that is 100. So therefore, if you observe the options answers here, these three answers are, you can say these two are lesser than 100 meter, means you can remove them directly. And this is 0.29 is very less amount, because if you add 100 plus 2.455, then already your height of instrument is 102.455, which means your RL of B should be more than that. So you can neglect, you can remove that, the option C also. So you are left with only one option, that is 105.2. So directly you can select this if you think logically. And this is the question asked for refraction correction. So the refraction correction for 100 meter is So that means we normally put it in kilometers. So the correction for refraction is 0.0673 meters. And here is a problem for reciprocal leveling. Reference reciprocal leveling is we will have a two set of readings taken, one at having setting the instrument near station A, we have two observations, and setting the instrument near B, again we'll have two observations, two readings observation. So directly we can substitute them, and we can find the RL of this, which is taking the difference of two, and we can find the RL by using this formula, that is here. So this HA represents the reading which is taken when the instrument is near A, the staff reading taken near A, and HB is the staff reading taken at B. Similarly, HA dash and HB dash means when instrument is placed at B, the respective readings taken at A and B. So you need to take the average of these two, you will directly get the what is the true elevation between them. So for this problem, if you have to calculate HA is 2.1, you can say this is HA, HB, HA dash, HB dash. So therefore, so this here, so now it becomes 2 point, you have to see whichever is having more value, from that you deduct the lesser one. 3.81 minus 2.165 plus 2.355 minus 2.14 whole divided by 2. So this will give you a true elevation or the difference in elevation A and B point. So the answer will be, it is actually, if you calculate, it will come 1.545 meters. This is the correct answer. So you solve this, you will get H as 1.545 meters. So next topic is we have curves. So we have two types of curves. One is horizontal and vertical curve. And in horizontal curve, we have a circular curve and a transition curve. Where in circular curve we have a uniform radius. In transition curve, we will have the radius will be varying from point to point. So that is, this is a smooth curve, you can say. And curve means same radius or a single radius. Compound curve means having multiple radius, two radius, and reverse curve is, it is like in a S shape. So radius of length or a different length. So it is also, reverse curve is also called as S curve. And we have in vertical curve we have summit curve and the valley curve. So the summit curve is like this, that is you will be climbing upward first, then you will be coming down, and a valley curve will be like this for when you are considering the vertical elevation into consideration. So here is a normally on curves, so not a lot of questions asked. There was one question asked in the gate: two straight lines deviate at an angle of 60 degree. The radius of a curve joining the two straight line is 600 meters. Then what is the length of the long chord and mid ordinate? So you have a formula that is for long coordinate and mid ordinate. Please uh, go through this particular concept, where you can see the answer is 600 and mid ordinate length will be 80.4. So there is another question, additional questions I have. So the required slope correction for length of 80 meter along a gradient of 1 in 20. So that is, what is the slope correction? So slope correction formula we have. So using that slope correction formula, you can calculate this length. So that is comes out to be 7.5. Which of the following is not correct statement? First statement is basic principle of surveying is to work from whole to part. So this, which is not correct. So which means at this point this is correct. Contours of different elevations may be intersected each other in case of an overhanging cliff. Yes, of course. When you have a cliff, that means sudden fall. So this particular point on the top and at the bottom both will be having different elevations. So that is where only contours can intersect, otherwise nowhere else. So this is also correct. Planimeter is used to measure the area, of course. The first reading for a level is called foresight. This is wrong. First reading is always backside, and the last reading what we take from the leveling uh, station from the station is foresight. Last reading is foresight. So option is correct answer is D. The latitude and departure of a line AB are plus 78 meters and minus 45.1 meter respectively. The whole circle bearing of the line AB is. So they are given in latitudes and departure. So we need to calculate the whole circle bearing. So that is, so we have the latitude in terms of as distance is 1 and departure is 40. So latitude is the one which is parallel to the north south. So positive means it will be uh, above this reference x-axis. Above this x-axis is latitudes are positive, and below this x-axis is negative. Departure, similarly, departure is now the reference line will be y-y axis. Anything towards the right is positive. Anything towards the left is negative. So departure is negative here, departure is negative here, and latitude is positive here, which means it comes under the fourth quadrant. So therefore, so your latitude is, this length is 78 and this length is 40.1. So you have to find what is the actual angle of the whole circle bearing. So this you can see here, it is in the fourth quadrant with respect to whole circle bearing. So fourth quadrant means it is lying in, only one option is there, 330 degree. So that is the correct answer here. The reduced bearing of a 10-meter long line is uh, north 30 degrees. The departure of the line is. So we have just gone through this. Northeast means this is the one, east, north, this is 30 degree. This length of the line is 10 meters. So they are asking what is the length of the departure. So departure means this angle, this length. This length will be equal to departure. So that length will be normally if you take uh, this side, this side and this side will be same length. So which is nothing but opposite side. So departure will be given by L times of sine theta. So L is 10 and sine theta is 30 degree. And if you solve, you'll get the answer which is 5 meters. Sine 30 is nothing but 0.5. So 10 into 0.5 is 5 meters. The rise and fall method provides an arithmetic check on backside and foresides, intermediate side, backside and intermediate side, or for backside, intermediate side, and foreside. It actually gives the check for all the three, that is backside, intermediate side, foresight. But height of instrument method, rise and fall method will give for all, but height of instrument method will give for backside and for only. So these are the some of the uh, repetitive questions asked in the geomatics. So I hope this will be helpful for you, and please go through the contents and solve more problems on these topics. And with this, you can see here at civil engineer there is no such thing a little mistake. Even there is a small bifurcation, so the bridge will not connect. So there will be certainly gap. So therefore, try to bridge your gap. Try to cover up the difficult subjects and do well in the gate. And all the best for your gate examination. Thank you. Thank you, everyone.